Hey guys, welcome back to Becky's World of Math. Today we will be investigating a logarithmic function. Now what they mean by investigate is create the four faces of a function with the information given to you. The four faces of a function are a graph, a rule, a word problem or context, and a table. We should also find the domain and range and asymptotes the graph may have, and record everything that seems important. So here's the question we are using. Right off the bat, we have two of the four functions that we need. The two that we already have are the rule and the context or words. So that's all set, and now for the table. You can see that here that I plugged -5 through 5 into the x column of the table, but x equals 0 extremely stands out because it doesn't have a y value. This is because x equals 0 is any logarithmic function's asymptote. An asymptote is a line that you can get as close to as possible, but you will never touch or intersect. The reason why x equals 0 is because logarithmic functions are the inverse of exponential functions. And an exponential function's asymptote is y equals 0, as you can see here. Now, going back to the table, you can see that in the y column, 1 and -1 have the same outcome. Same for 2 and -2, and so on. This is because of the square and the rule. Now, to graph out my points. We can see that there are two graphs that actually mirror each other. This is because of the square that imitates a quadratic function. If you look at a quadratic function, the two sides of the graph are just mirrored around the line of symmetry that is the x of the vertex. In this graph, the line of symmetry is x equals 0, which is the asymptote. Now to find the domain and range. Domain is a set of input or x values that allows the rule to work. Since the graph on the left continues forever in the negative direction, the lowest value is -infinity. A parenthesis goes in front of it instead of a bracket because it is not a definite value. Then put a comma. Because 0 is the asymptote, it will be the highest input value for that graph. Put a bracket after it because it is a definite value. But we're not done. The lowest input of the graph on the right is 0 because it is a definite value. The lowest input for the graph on the right is 0 because it is the asymptote. Place a bracket in front of it because it is a definite value. Place a comma next to the 0, and since the graph continues forever in the positive direction, the highest input value is +infinity. Place a parenthesis after it because it is now a definite value. Now to find the range. Range is a set of output values, or y, which results from using the rule. But because both graphs mirror each other, their range will be the same. They both continue in the negative direction of y, so their lowest output will be a -infinity. Place a parenthesis in front of it because it is not a definite value. Place a comma after it, and then they both continue in the positive direction of y, so their highest input will be a +infinity. Place a parenthesis after it because it is not a definite value. And now we're done investigating it. We have our rule, word problem, graph table, domain, range, asymptote, and recordings of anything that seemed important. Logarithmic functions are seriously used in the real world. They are used to measure the decibels of sound. And that's it, guys. Thanks for watching, and I will see you next time. Bye!